look at finding the golden level of capital and savings rate in our Solow model without any population growth and without any technological progress. So let's start with part A. Oh, sorry. So the golden rule level of capital. So sorry, the golden rule. That's the first part asks us to find this. The golden rule level of capital, which we're representing as K gold, the golden rule level of capital per worker, to be more precise, of capital per worker. The golden rule level is given by. So where do we find the golden rule level of capital per worker? It's given to us by where NPK is equal to delta. But remember, MPK is essentially marginal product of capital per worker. So it's marginal product of capital per worker, right? So this is like slope of our per worker production function, slope of per worker production function, right? And delta is the depreciation rate. So this is the depreciation rate. And this is essentially now Solow diagram. So in Solow worker production function in Solow diagram, right? Let's just add this, right? The per worker production function that we draw, right? And depreciation rate, this is the slope of the depreciation or break even, or what we call break even investment line in our Solow diagram, right? Line in Solow diagram. Right, so this is what we know now. So the golden rule level capital is given by where MPK is equal to delta, where now we're given the delta is equal to 0.1, right? And as Y, and we know our output per worker is equal to K1 by 2, right? This is a per worker production function given to us, right? Output per worker is equal to square root of capital per worker. Then from here we can see the marginal product of capital per worker is the derivative of output per worker with respect to capital per worker, which we know will just apply the power, will take the power down, will reduce the power by 1, right? So we just need to equate this with this, right? That's all we need to do now to find the golden rule level of capital per worker. So K gold is given as 1 by 2, K minus 1 by 2. So this is marginal product of capital per worker is equal to the depreciation rate. Then obviously we can just do this K minus 1 by 2 is equal to 0.2, and then this just becomes K 1 by 2. Take a reciprocal on both sides, 1 by 0.2. So this is K gold is equal to 25. So this is the golden rule level of capital per worker. If you want to do part B now and want to find the golden rule level of savings rate that allows us to reach the golden rule level of capital per worker. So basically the goal is we want to find S such that two conditions are met, right? We have steady state, right? The savings rate that you want to find has to be such that we have steady state, because remember, golden rule, the point is that you want to maximize steady state consumption per worker, right? So the first thing is we want to choose S such that we have steady state, right? Because the goal is that you want to maximize steady state consumption per worker in the golden rule, right? Like over here, if you recall, maximizes consumption per worker in steady state, right? So we want steady state thing here. So we have steady state, which means that delta K has to be equal to SFK minus delta small k is equal to 0, right? We have steady state, which means that capital per worker is constant. And for that change in capital per worker, which we know by the capital accumulation equation in the basic Solow model, that investment per worker minus depreciation per worker is 0, right? So we want to have steady state, which means the change in capital per worker is equal to 0. And this is through the capital accumulation equation in worker term. Second, we want is that K is equal to K gold is equal to 25, right? Because see, this will ensure, the first condition will ensure that we do have steady state, which we need for the golden rule. The second will ensure that we're maximizing consumption in this steady state, right? So we want to find S such that we maximize steady state consumption per worker. This will ensure the steady state part, and this will ensure that in the steady state, consumption per worker is maximized. So we need to choose S, right? So we need to choose S is equal to S gold to ensure that, right, to ensure that, so we want get delta K, which is, so we want to choose S is equal to S gold to ensure that S gold and F gold, FK gold minus delta K gold is equal to 0, right? That's what you want to do. You want to choose S is equal to S gold to ensure that when I plug in S is equal to S gold over here, right, and K is equal to K gold over here, we get delta K is equal to 0, right? Where we know what K gold is. We know K gold is 25, right? And we know that as Y is equal to Fk is equal to K1 by 2, this is a per worker production function. We know Fk gold is equal to 25 power 1 by 2 is equal to 5. And we know that delta is equal to 0.1, right? These are the things that were given over here, right? So we want to choose S to ensure that change in capital per worker is equal to 0. When I plug in S is equal to S gold, and we want to use K gold value, right? K is equal to K gold to make sure maximizing consumption in the steady state. Now we know K gold is 25. We know what FK gold is. We're just plugging this K gold value in a per worker production function, and we know delta. What is delta, right? So S gold times 5 minus 0.1 times 25 is equal to 0. So S gold is equal to 50%. So this is how we can find the golden rule level of savings rate also once we have the golden rule level of capital per worker.